Hi, and welcome to the video about finding an inverse graphically. To begin, I just want to describe what an inverse is, since this is our first video about it. An inverse is something that undoes something else. So for example, the inverse of adding 1 would be subtracting 1. It gets a little bit more complicated when you're looking at functions such as the one before us. So here we have f of x equals 2 square root of x minus 1. Notice that there are many operations happening here, and I want to undo all of them. In the next video, I'm going to show you how to actually do that algebraically. But for now, I'm just going to show you what the graph of its inverse would be. To begin, I'm going to graph f of x. So, I'm going to notice that this is the graph of the square root of x, and then it's shifted, let's see, 1 right, and it has a vertical stretch by a factor of 2. So here's my square root of x table, 0, 0, 1, 1, 4, 2. So let's move those points 1 to the right. So 0, 0, 1 to the right. Its y value is 0, so when it gets multiplied by 2, it doesn't change. So there's our first point. Next point is at 1, 1. Move it right 1. Its y value is 1. Multiply that by 2, we get 2. So I have a point at 2, 2. And our last point starts at 4, 2. Move it right 1. Its y value is 2. Multiply that by 2, we get 4. So now I'm at 5, 4. And I'm going to label that f of x. There's the graph of f of x. It's pretty simple to get the graph of its inverse. And I'm going to introduce you to this new symbol here. That looks like f to the negative 1 power. I'm actually going to say that as f inverse. It's actually not an exponent, it's just a symbol. I know math is confusing. Sometimes we make symbols that look like something else. So to get the inverse, you're going to switch x and y values. So notice for our f of x graph, there's a point at 1, 0, another at 2, 2, and another at 5, 4. To make the switch, to get the inverse, we would get points at 0, 1, 2, 2, and 4, 5. I'm going to graph those over here now. 0, 1, 2, 2, and 4, 5. And if I connect those, you'll notice it looks like half of a parabola. And that's exactly what it is. Let me label it here. F inverse of x. I want you to notice that this red graph and the blue graph are actually symmetrical through this dotted line. And that dotted line I just drew in is the line y equals x. Notice that when you reflect that blue graph over that dotted line, you get the red graph, and all it does is switch x and y. Let's try another example. Oh, nice. This time I gave you the graph. Let's take some points on it. I like starting with the vertex. So the vertex is at 0. Actually, I'll make a little table to make this a little easier here. So our vertex is at 0, negative 4. Let's take some other nice points. I'm going to try to stick with actual nice points here. I know it looks like negative 2, 0, and 2, 0 points, so I'm going to put those on my table. So negative 2, 0, and 2, 0. And we want to graph the inverse. So it's inverse, or the G inverse of x table. Again, we're just switching those x's and y's. Would get me -4, 0, 0, -2, and 0, 2. Ooh, notice we've never had that happen before in one of our tables. 0 gives us -2, but it also gives us +2. Oh, something weird is happening here. Let's graph those. -4, 0, 0, -2 is here, 0, +2 is here. Ah, so remember that this right here is our vertex. So it looks like a parabola that's on its side, a sideways parabola. Ah, and that's why this looks so weird. A sideways parabola isn't a function. It fails the vertical line test, right? All of these points are failing that vertical line test. So actually, see this notation right here, G inverse of x? I really shouldn't be using it, because I only use it for functions, but we'll use it anyway, because it does mean inverse. Let's do one more together. Ooh, a circle. We haven't graphed circles yet. That's okay, I gave you the graph. I think it's a good idea to start with the 4 points that are pretty noticeable on this circle. So I'm highlighting them right now. So remember, you could actually make the graph without making the table. I could do that right now to demonstrate for you. So if I start with the point 4, 3, and switch those, I'm going to get 3, 4. And now with the point 7, 0, I would get 0, 7. And then 4, -3 would get me -3, 4. And 1, 0 gets me 0, 1. Ah, and there's our new circle. And again, something to point out. Remember I mentioned that line y equals x? Right there. If you notice that the inverse is actually at these points here, you'll see that again, it's just a reflection over that line. Alright, how about you try some now?